I'm David Johnson, and I'm going to be talking about polynomial functions. So step one, how do you do this stuff? Well, first off, without even doing any math, you can figure out if it's a John Travolta or a land the plane graph. What the heck does that mean? Well, let's scroll down a little bit. So there we go. First of all, if you have an x to the raised to the an odd number, as you can see here, here, and here, you can automatically tell it's a John Travolta graph. That's what it means. I never seen anything with John Travolta, but I guess that's what it's about, kind of going up and down. And if it's raised to a even number, you could tell, oh, my bad guys, it's gonna be a land the plane graph, because the guy, land the plane, he raises both arms up, it's a land the plane graph, so both ends are going upwards. Now, with the land the plane graphs, as you can see, if it's a squared number, it's a bouncer. You see it bounces right there, and with the 6, it has 3x squareds, so that means it bounces 3 times. 1, 2, 3. So with that, you don't even need to do any math, and you can already tell what the graph's gonna kind of look like. So let's dive into our first example problem. Are we there? So we're gonna start off. F of x equals x cubed minus 2x squared plus x. Well, that's kind of strange. Let's figure out how to graph it. Step number 1, let's factor out x. You guys know how to do this stuff, factor out x squared minus 2x plus 1, easy peasy. Factor it out. You get x minus 1, x minus 1. And that just comes out to x minus 1 squared, since there's 2 x minus 1s. But, David, what do I do now? Like, how do I graph that? What? Well, let's turn it over. So we're back up here to the top, x minus 1 squared. So as we're flipping it over, hopefully you got some time to think it over. What do you do? First, x-intercepts, or you could call them zeros. So by doing this, you could plug in x equals 0, as you can see here, or x minus 1, which equals 1 right here. And since there's a squared right there, you do it twice. That's very important. So now that we know the zeros, we could plug in x to the 0th right here. So it's just right smack in the middle of the graph. And then you have x equals 1 right there. But what do you do if you have 2x plus 1s? Ready, class? What do you do? 3, 2, 1. It bounces. Good job, class. Well done. So with that, we could tell that, oh, totally forgot. What type of graph is it? It's a John Travolta.
Sure. Oh, here we go.
All right, so after that, you found out that's a John Travolta graph. That's it. You just make sure the left is going down, the right is going up, because it is a positive 1. So
I'm Danny Goodman. Let's do some math. Okay, today I'm going to be teaching you how to solve equations of 2 and 3. Let's look at an equation of 3. So here we have our example problem, and what I want to do is I want to eliminate the c's. So we're going to take the first equation here and the third equation, we're going to set them up like this, and we're going to end up getting 3a plus 2b equals 5. So now we want to do the same thing with the next two equations. So we want to take a plus 2b plus 3c equals 2, and 2a plus b minus c equals 4, and we want to line them up. And this one's a little bit trickier. You're going to have to multiply the bottom one by 3 to eliminate the c. But then once you do that, you get 7a plus 5b equals 14. Now what you're going to do is take this equation that you found in this equation, and that's step 2. You're going to set them up, and I think we should eliminate the b's. So multiply the top one by negative 5, so you get negative 10. The bottom one by 2, so you get 10. And then the b's will cancel, and you're left with negative 15a. Oh, and you're left with negative a equals 3, which is a equals negative 3. Now, steps 3, 4, and 5, we're going to plug and chug. So, we're going to you can take any equation and plug a back into it. I took this one right here, and I substituted negative 3 for a. So I ended up with negative 21 plus 5b equals 14. And then you end up getting b equals 7. And then, now that you have a and b, you can plug it into You can plug A and B into any equation you want. I chose this one, and I got -3 plus 7 plus C equals 1, which gave me C equals -3. Now, like the A plus student I am, I always check my work, and that's what we're going to do. So over here, we have our A, which is -3, our B of 7, and our C of -3. -3 plus 14 minus 9 equals 2. 2 equals 2. That's how we know we got the right answer. Now let's slow things down a bit. What you said? Yeah? Two-step equations. Let's take a look at the example. We have y equals 2x plus 1, y equals -4x plus 2. First way you can solve is by doing substitution. Now, what I did was I thought that this was y equals -4x plus 2, and since there's a y here, you're actually allowed to set this equal to that one. So that's what I did here. -4x plus 2 equals 2x plus 1, and you'll end up getting x equals 1/6. Then to find y, you can choose either of these equations. I think I chose the top one right here, and I plugged in 1/6 for x, and then I ended up getting y equals 8/6, which is 4/3. And then you should check your work. Plug in 4/3 for y, plug in 1/6 for x, and you find that 4/3 equals 4/3.
Hey, it's Marcus, and today we're going to be modeling exponential growth and decay. Hello, today we're going to be using two types of models. We're going to be using a growth model and a decay model. As you see at the top, I have my word problem, which says a person places $50,000 into a bank account. It has an annual interest rate of 8%. How much money will be in the account after 40 years? So for this equation, we're going to use the compounded continuously equation, which is P equals P to the O times E to the RT. So our P equals final amount, our P to the O equals initial amount, our R equals the rate of growth, and the T equals time. So first we're going to plug in our equation. So as we see, our initial amount is going to be $50,000. So we're going to put that in as the P. The E is always going to be 2.72, so we do not need to place that in any differently. The percent is 8%, so that's going to be, as a decimal, 0.08, and it will be compounded over 40 years. So we have to put the 40 in. Then, next we will multiply these two numbers and get 3.2. After that, we take e to the power of 3.2 and multiply that by 50,000. As you can see here, I have e to the power of 3.2, which is 24.5325302. Multiplied by 50,000. After you multiply that all out, you should get a much larger number, which is 1,226,626.51. You have to remember to always round to the nearest cent so that it is a realistic number, and that is our growth model. Now, let's take a look at decay models. So now we have a different word problem having to do with a scientist that has researched a disease in a community with a starting population of 30,000 people. The disease has a mortality rate of 6%. What will be the population after 12 years? Let's take a look at the first step. So we have the equation A equals P multiplied by 1 minus R over N times, or to the power of N multiplied by T. A equals the final amount. The P right here equals the initial amount. The R equals the rate of decay. The N equals the number of times compounded, and the T equals the number of years. So after we have all that, we're going to enter in our information. So we know that there are 30,000 people initially. And then we take the 1 minus the percentage, which is 6%, which would be 0.06 divided by 1. And we put all of that to the power of 12 times 1. The next step is multiplying the 12 times the 1, which is a simple step, but we still need to keep track of it for future problems. So after we find that, we subtract the 1 minus the 0.06 and put that to the power of 12. After that, we get 0.475920,314. Then we multiply that by 30,000 people, and we end up with our rate of people dead after 12 years. After 12 years, 14,278 people will have died, and 15,722 people will have remained.
So for binomial theorem, first you want to look at the question. You want to see how many times it is multiplied by the exponent. And for this example, it's multiplied by 4. Now, first step, you want to draw Pascal's triangle. And this is how you draw the main basis of Pascal's triangle. For example, we are in 1, 4, 6, 4, and 1. Now when you look here, the variables descend going one way, and descend going the other way. Now, step 3. You want to substitute for A and B. Now look what A and B is. A is X, and B is 2Y. Now when you substitute x and 2y, you get this order. Now, when you expand, you finally get this answer. Now, for the next equation, what you want to look at is if the exponent is multiplied by too much and if you want to use Pascal's triangle or not. Right? For this step, you see the exponent is 13, and you want to find the sixth term. Now you look at this equation, n, cr, a, n minus r, b, r. Now you always want to know that the term is r minus 1. So when you plug it in, you plug in 13, c, 5, and then you plug in x since it is a. So it's x to the 8th, and y is to the 2y to the 5th. And when you expand it, you get 1,287 times x to the 8th times 32y to the 5th. And the final step for this equation is you expand it, and you get 41,184 x to the 8th and y to the 5th. Now let's look at rational functions. Now let's look at this equation, 1 over x minus 3. First, we want to find the domain. And the domain here would be negative infinity, 3, and 3 to infinity. Now the way you would graph this is you would see where the vertical asymptote is. The vertical asymptote is at positive 3. So you would write a dotted line on positive 3. And now to graph it, you would implement the points and you would get this graph. Equation 2. Now let's look at what happens when you have a vertical asymptote and a horizontal asymptote. For this equation, it's y equals 2x over x minus 2. Now, this one has a horizontal asymptote, and that means that the degree of the variables are equal. So what you would do is you divide the top over the bottom, and you would get 2 over 1, which is 2. Now after this, you look at the domain, just like the first problem. The domain is negative infinity to 2, and 2 to infinity. Now first, we find the vertical asymptote, and the vertical asymptote is 2. And now we find the horizontal asymptote, which is different from the first problem. And again, this vertical asymptote, as we found, is also 2. So you would put these two dotted lines, and now we do what we did in the first equation, and we implement the points, and we get this. Now let's look at the third equation. Now let's look at this problem. This problem has a slant asymptote. And in order to find the slant asymptote, you need to see the variable and see if the degree of the variable is higher than the bottom one. In order to find it, use polynomial long division. And now, after you find the slant asymptote, first thing you want to do is you want to always make sure that you put the slant asymptote on the line so you remember. And now, what you want is to find the domain. And how we found the domain previously is we looked at the denominator. And the denominator is negative 1, which means that the domain is 1. And now, in order to find the y-intercept, we would put the zeros in all the x's and variables, and now you get negative 2. Now look at the equation. The first thing you want to do is you want to make sure you put the right points. You want to make sure the domain is 1, and the y-intercept is negative 2. After you draw the first part, the curve, then you also want to put the next part, which is the bottom part that is also a continuous part of the graph. This one, right? Yeah. Okay, good. Now let's look at the last equation. The last equation is probably one of the most difficult, very difficult equation. First thing you want to do here is you want to find the domain. Now the domain here is very tricky. Because first thing you want to do is you want to factor this out to be x plus 3 and x minus 3. And that means you have a whole. And that is negative infinity, 3, negative 3, and negative 3 to 3. And then finally, 3 to infinity. After you find that, you want to find the x and y intercepts. However, since the top is a 0 and there's no intercepts in x, then y is 0 too, since the top is 0. And finally, you want to see the horizontal asymptote. And the horizontal asymptote is 2, since the variables in the equation are the same. Now, for graphing, you want to put the graphing as horizontal asymptote as positive 3 and a vertical asymptote as 3 and horizontal asymptote as 2, and the last vertical asymptote as negative 3. Now you want to make sure that you don't put any x-intercepts, since this graph does not have any x-intercepts. So what you do is you draw the graph down, and since there's no x-intercepts, you continue the graph from here, and you draw it this way. And finally, you want to also have an infinity going the other way, so you draw the graph going this way.
Thank you for watching our video.